Hey guys, today we're going to do notes over solving trig equations. So basically, looking at this first example, we have 2 sine x minus 1 equals 0. Our goal is to isolate that trig function. So we're going to move the 1 over first by adding it, and then we're going to divide by 2. So basically what we're doing, if you think about your graph for the sine function, it looks something like this. Goes on forever in either direction. We have a domain of all real numbers. So what you're looking for is when this graph, when the y value is 1/2, right here at the highest point was 1. So 1/2 is about right here and here and here and here. And this goes on forever. So all of these places where I have red dots, those are places where the sine of x is going to equal 1/2. Well, one thing we should remember is that sine is positive in the first and the second quadrant. Where the sine is 1/2 is when you have a reference angle of pi over 6. So it's pi over 6 in this in the first quadrant, and it's over here in this quadrant, it's going to be 5 pi over 6. So those are the two angles on the normal unit circle graph where the sine of x is equal to 1/2. So we want every single one of those. That means anywhere on the graph. So you remember coterminal angles are going to have that exact same sine value. So to get the coterminal angle, you add the period, or you add 2 pi. I'm just going to write here that we're adding the period. But for sine, the period is 2 pi. 2 pi divided by b, our b value is 1, so it's just going to be 2 pi. So your answers are going to be pi over 6 plus 2 pi. Now we can keep adding that period or that 2 pi over and over and over again. So we're going to put 2 pi in. And then another answer would be the 5 pi over 6 plus 2 pi in. So this takes care of all the places where the sine of x is equal to 1/2. I probably should say that n is the set of all integers, because it could be a positive number or a negative number, just whole numbers, where the sine of x is equal to 1/2. Okay, so now we're going to do another example. This time, though, specifically, they're saying only from 0 to 2 pi. So we don't want every single one. We only want the ones going from 0 to 2 pi. Up here on this graph, 0 to 2 pi is this window right here. So we only want 2 solutions where it happens, or however many solutions for each individual situation. So we're going to need to get all of our trig functions on the same side. I'm going to move this sine x over here to be with that sine x. So I'll have square root of 2 equals, I'm going to subtract that sine x, so that becomes a negative 2 sine x on the right-hand side. Now I'm going to divide by negative 2, so that gives me a negative square root of 2 over 2 equals sine x. Well, remember the sine function is negative in the third and the fourth quadrant. And where it's equal to a negative square root of 2 over 2 is at any pi over 4 reference angle in those quadrants. So in quadrant 3, our x equals, the pi over 4 in quadrant 3 would be 5 pi over 4. And then in quadrant 4, our pi over 4 reference angle is 7 pi over 4. So these are the 2 answers for that. We only have 2, and we don't put the plus 2 in pi because we don't want to keep going around the circle multiple times. We only want to go from 0 to 2 pi. So pay attention to whether or not we put 0 to 2 pi on there. All right, let's do another one. I'm going to move this up a little bit. Okay, on example 3, again, we're trying to isolate the trig function. So I'm going to move over the 1. And then I'm going to divide by 3. So now we're still trying to solve for this. We need to isolate this. This function tangent is being squared. So to unsquare it, we take the square root of both sides. And when you take the square root in order to solve, you have to remember to do the plus or minus, because you have positive and negative values where that can happen. So what we know is that the tangent of x equals plus or minus, take the square root of the top and the bottom, so that'll be 1 over the square root of 3. So you technically have all 4 quadrants where that's going to happen, where because it's positive and negative values. Remember, tangent's y over x, so it's 1 here, square root of 3 here, 2 here. So it's pi over 6 reference angle in all 4 quadrants. So if I had just said from 0 to 2 pi, then your answers would have been pi over 6. And then in the second quadrant, it's 5 pi over 6. In the third quadrant, it's 7 pi over 6. And then in the fourth quadrant, it's 11 pi over 6. So that would be your answers if we had put 0 to 2 pi. I didn't put that on in this case. So when we don't put 0 to 2 pi, what we're finding is the general solution. So the general solution for this would be pi over 6 plus, you're going to add the period. For tangent, the period is just pi over b, and our b value is 1 here, so it's just going to be pi in this situation. So I'm going to be adding in pi to that. If I add in pi, I could rewrite it as 6 pi over 6. That's also going to take care of that answer as well. So I only need the pi over 6 plus n pi. I also need the 5 pi over 6 plus n pi. And when I add a pi to 5 pi over 6, I'm going to get the 11 pi over 6. So these two answers take care of all of the solutions for this one. And this one wanted the general solution, so I have to write it like this. And technically, I should also say that n is a set of integers. All right, let's do some more. Okay, on the next one, again, you need everything to be on the same side together. You can't divide through by cotangent in this case because you'll lose some of your answer choices. So you need to move this over here by subtracting it. So that's that's cotangent x, cosecant squared x, minus 2 cotangent x equals 0. All right, now that I've moved it over, I have two terms. This is one term, and this is a second term. They're separated by this minus sign right here. If you'll notice, both of those two terms have a trig function in common, cotangent x, and I'm going to factor out like a greatest common factor. So when I do that, I'm left with, in the first term, cosecant squared x. In the second term, I'm left with minus 2 equals 0. And if you'll recall, anytime we factor in order to solve, we set each factor equal to 0. So I'm going to work this over here. So that means cotangent x equals 0. Also, cosecant squared x minus 2 equals 0. And now I'm going to continue solving this by thinking about where is the cotangent of an angle. When I take the cotangent of an angle, when do I get 0? Well, remember, cotangent is x over y on our unit circle. So you're looking for where the x value is 0, which is right here at 0, 1, and down here at 0, negative 1, which is at pi over 2 and 3 pi over 2. So for this one, my solutions are pi over 2 and 3 pi over 2. If I'm looking if I finish solving this other one, I'm going to move the 2 over, so I get cosecant squared x equals a positive 2. And then I'm going to take the square root of both sides, so I get cosecant x equals plus or minus, because I'm taking the square root of 2. All right, so cosecant, you're looking for all four quadrants. So you've got all four quadrants where, remember, cosecant is r over y. So you're looking for where the r value is square root of 2 and the y value is 1, which is at a 45-degree reference angle. So if they had asked me for the solutions from 0 to 2 pi, which they did not, I would give all four of those. I would say pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, as well as these two here. So if my answers had been from 0 to 2 pi, I would be finished there. This one wants the general solution, though. So we would say, so I'm going to uncircle those. I'm going to say pi over 2. Whoops, I have no room here. Let me write it over here. Pi over 2 plus, now this pi over 2 was for the cotangent. Remember, cotangent's period is pi. So we're going to say pi in. And then the other one is 3 pi over 2. But if I add pi to that pi over 2, I'm going to get that 3 pi over 2. So I don't have to write it again. Then we've got pi over 4. Now the period for cosecant is 2 pi, so I'm going to be adding 2 pi to that n times. When I do that, 2 pi is the same thing as 8 pi over 4. Yeah, I'm going to have to do all of these. So we've got also 3 pi over 4 plus 2 pi n. I've got 5 pi over 4 plus 2 pi n. This is going to take care of all of the coterminal angles. And then 7 pi over 4 plus 2 pi n. I must have erased that. Okay, so again, this is where n is the set of all integers. This is the general solution for this one. All right, let's do another one. By the way, technically, I could have just added pi instead of 2 pi, and it would have taken care of this one and this one, where you wouldn't have to write them, but either answer is fine. All right, now this next one, we're going to have to factor it. And I am only going to do it from 0 to 2 pi this time. So what I want you to think about on this next one is if we had asked you to factor something like 2m squared minus m minus 1 equals 0, and ask you to solve that by factoring, you would factor it to be 2m times m. That's what gives us 2m squared. We need a 1 in here, 1 and 1 on either side to get this negative 1. I need 1 to be positive and 1 to be negative. So I'm going to do a positive here and a negative here, so that when I multiply this back out, this gives me a positive 1 in m, and this gives me a negative 2m, and they combine to be a negative m. So this is going to factor the same way. We just have sign. So we're going to say 2 sine x plus 1 times sine x minus 1 equals 0. And then you're going to set each factor equal to 0. So 2 sine x plus 1 equals 0, and sine x minus 1 equals 0. Solving for the trig function, or isolating it, I get sine x equals a negative 1/2, and sine x equals 1. All right, where sine is negative is in the third and fourth quadrant, and we're looking where the y value is negative 2, and the hypotenuse, or sorry, negative 1, and the hypotenuse is 2. So that's a 30-degree or pi over 6 reference angle. So in the third quadrant, that's 7 pi over 6, and 11 pi over 6 in the fourth quadrant. Where sine of x is equal to 1 is up here at pi over 2. So all of my solutions are x equals 7 pi over 6, 11 pi over 6, and 3 pi over 2. So those are your solutions for that one. All right, let's do another one. Okay, on this next one, I want to factor again. The only problem is I have a sine squared here and a cosine here. So I'm going to have to use my Pythagorean identity, cosine squared theta plus sine squared theta equals 1. And the fact that sine squared theta, if I were to move this cosine squared over here, is equal to 1 minus cosine squared theta. So I can replace this sine squared theta with this right here. So I'll do 2 times 1 minus cosine squared theta plus 3 cosine theta. I'm sorry, I should be using x, huh? Can I erase this? There we go. Cosine squared x, and then 3 cosine x minus 3 equals 0. All right, I'm going to distribute the 2. And then combine like terms. So we've got negative 2 cosine squared x plus 3 cosine x. The negative 3 and the positive 2 combine to be negative 1. And I personally hate it when the one that's squared is negative, so I'm going to divide through by negative 1. So that gives me 2 cosine squared x minus 3 cosine x plus 1. As long as you have an equal sign and you divide every single term by that negative 1, you haven't changed the equation. All right, so now I can factor. It'll be 2 cosine x and cosine x equals 0. 1's going to go here and here. And then we need both of these to be negative, so they'll multiply to be a positive 1. And then when you multiply it fully out, you'll get a negative cosine x there and a negative 2 cosine x here, and they'll add to be that negative 3 that we have in the middle. All right, set each factor equal to 0, so I'm going to do it over here. We've got 2 cosine x minus 1 equals 0, so when I solve that, I'll get cosine x equals 1/2. For the other one, I have cosine x minus 1 equals 0. So solving it, I get cosine x equals 1. Where cosine is a positive 1/2 is going to be in the first and fourth quadrant. And it is at a 60-degree reference angle in those two quadrants. So x equals pi over 3 and 5 pi over 3 for those two quadrants. And then cosine of x is equal to 1 right here at 0. So 0 is also a solution. Now, if I had asked you to go from 0 to 2 pi, then those would be your three answers. We didn't. We were wanting the general solution. So we're going to say pi over 3 plus the period. Now, we're dealing with cosine. So my period for cosine is 2 pi. So we'll say 2 pi n. That gives me all the coterminal angles. And then 5 pi over 3 plus 2 pi n. And 0 plus 2 pi n. So this is the general solution, which is what they're looking for that problem. Okay, I'm going to move this up some more just to give me more room. Okay, this next one's a little trickier. There's no way, unless I graph it, for me to see when cosine x plus 1 is equal to sine x. If I move this over here, it's not really going to help me much because I have two trig functions in there. I can't factor anything, nothing's squared. So what I'm going to do is I'm going to square both sides. So that'll be cosine x plus 1 squared equals sine x squared. So as long as you do it to both sides, you haven't changed the equation. But remember, cosine x squared is the same thing as saying cosine x plus 1 times cosine x plus 1. You're squaring it, so you're multiplying it by itself. You got to multiply those together, you get cosine squared x. Got to multiply those together to get cosine x. Got to multiply those to get another cosine x. And then you've got to multiply 1 and 1 together to get 1. So that simplifies to be cosine squared x plus 2 cosine x plus 1. So that's what I've got over here. I've got cosine squared x plus 2 cosine x plus 1 equals, over here I have now sine squared x. So I've got mostly cosine squared. I'm going to have to change this using my Pythagorean identity. This says cosine squared x plus sine squared x equals 1. So move over that, and I can replace it with 1 minus cosine squared x. I'm just going to rewrite all this real quick. Okay, now we need all of our trig functions or everything on the same side. So I'm going to move these to the left side. So when I move them, I'll change their signs. That negative cosine squared becomes positive, and it adds with the other cosine squared to be 2 cosine squared x plus 2 cosine x. Now, when I move that 1 over, it's going to cancel out, so it's just equal to 0. Now we have two terms. They both have 2 cosine x in common, so I'll factor that out, and I'm left with cosine x plus 1 equals 0. Now set each factor equal to 0, so 2 cosine x equals 0, and cosine x plus 1 equals 0. So when I divide by 2, I get just cosine x equals 0, and cosine x equals negative 1. And this time they're doing it on the interval 0 to 2 pi. So where cosine is 0 is when x is 0, because remember cosine is the x value on the unit circle. And that happens at pi over 2 and 3 pi over 2. So right now we've got the answers pi over 2 and 3 pi over 2. And then where cosine is negative 1 is over here at pi. So those are your three answers from 0 to 2 pi. Okay, this next one's a little trickier because we've now changed our b value in there. It's no longer a b value of 1, we have a b value of 3. So that means we've horizontally compressed it. You've made it a smaller cosine wave. Basically, you know, normally when we graph the cosine graph, it looks something like this. You're going to have 3 times as many waves in there as what you have in the normal cosine graph because you have horizontally compressed it. You might go on to Sari and look at y equals cosine x versus y equals cosine of 3x and see what how the graph differs. What's going to happen though is that we're going to have 3 times as many places whenever if I solve this one here, I've got cosine of 3t equals 1/2. You're going to have 3 times as many places where the cosine of an angle equals 1/2. So when you're solving this, we're going to isolate the cosine like we did. I'm going to solve one thing to think about is what I'm solving for is the angle. That 3t, the whole thing is my angle. So I'm going to say 3t equals, when the cosine is equal to 1/2, it's going to be in the first and fourth quadrant, and that's where you have a 60-degree reference angle. So at pi over 3 in the first quadrant, and then the angle equals 5 pi over 3 in the fourth quadrant. Now we're solving for t, so I still need to divide by 3 or multiply by 1/3 on both sides. And so that gives me t equals pi over 9 and t equals 5 pi over 9. All right, they didn't put from 0 to 2 pi, so we need the general solution. So we're going to say pi over 9 plus, I'm going to add the period. Remember, our period for cosine is 2 pi divided by b. My b value this time is 3, so it'll be 2 pi over 3, and that's what we're going to add to each of these. So we'll do 2 pi over 3 n, because you're going to do it, every time, every integer. And then also you have 5 pi over 9 plus 2 pi over 3n. I don't know if you can hear my dog snoring, I'm sorry. Anyway, these are my two answers for the general solution. Now, if it had asked for 0 to 2 pi, then you would have said pi over n, and you would have had to keep adding the period up until you got to 2 pi. Well, 2 pi is the same thing as 18 pi over 9. You need a common denominator. So when I add the period, I'm adding 2 pi over 3. I'm sorry, I don't know why I wrote plus. 2 pi over 3 is the same thing as 6 pi over 9. Because I'm going to add them, or multiply the top and bottom by 3. So you're going to add 6 pi over 9 to this pi over 9 to get 7 pi over 9. And then you'll add to 7 pi over 9, 6 pi over 9, to get 13 pi over 9. Now I can't add 6 pi over 9 again because I'll get 19 pi over 9, and that's past 2 pi. So right now what I've got for answers, if I'm doing it from 0 to 2 pi, it would be pi over 9, 7 pi over 9, 13 pi over 9 from that answer. And then the other one, we've got 5 pi over 9. Again, I'm going to add 6 pi over 9 to that, so that'll be 11 pi over 9. And then add 6 pi over 9 to that, and I get 17 pi over 9. So I thought I only had 2 answers, but because we changed the period, I have 3 times as many, so I have 6 answers if I'm doing it from 0 to 2 pi. Otherwise, you just have to take the answer you get and add the period to it for both of them. All right, on the next one, I'm going to isolate tangent, and this time we've changed the period again. So move over the 3 and divide by 3, so you get -1. So what we're looking for is the angle where when you take the tangent of it, you get -1. So let's see, the tangent's negative in the second and the fourth quadrant, and it's -1 at a pi over 4 reference angle. So our angle in the second quadrant is going to be 3 pi over 4. And then in the last quadrant, in the fourth quadrant, it's going to be 7 pi over 4. All right, I'm going to multiply both sides by 2. So it cancels here, and we're left with x equals 3 pi over 2. And then if I multiply the other one by 2, I get 7 pi over 2. Now, if I had used the restriction 0 to 2 pi, I would have to exclude this answer because it's past 2 pi. 2 pi is 4 pi over 2. I didn't do the 0 to 2 pi, so let's undo that. Oops. And let's write the general solution. So remember, pi has a period of pi, but you're dividing it by your b value, which is 1/2. So you're going to be adding 2 pi to each of these answers. So 3 pi over 2 plus 2 pi n, and 7 pi over 2 plus 2 pi n. Now technically, from this one, when you add 3 pi over 2, 2 pi is the same thing as 4 pi over 2. I'm going to get that 7 pi over 2. So I don't really need to even write this answer. This is just going to be the answer that I care about. All right, those are my general solutions for those. let's move on. Okay, on this one, it wants me to use the inverse trig function. So I'm going to replace secant squared with what it, my trig identity, 1 plus tangent squared theta equals secant squared theta. So that we have the same trig function in that equation. So 1 plus tangent squared, oops, did it again. Minus 2 tangent x. I'm going to go ahead and move the 4 over, so minus 4 equals 0. So combining like terms, I get this equation. If I were to factor it, I would do tangent x times a tangent x to get that tangent squared. I need a 3 and a 1 to give me the 3. I need it to be a negative 3, so one needs to be positive, one needs to be negative. I'm going to put the negative here and the positive here, because this will give me a positive tangent x, this will give me a negative 3 tangent x, which will combine to be that negative 2 tangent x. All right, set each factor equal to 0. So we get tangent x equals negative 1, and we get tangent x equals 3. Okay, so if I were going to do inverse trig, what that means is this one is not on the unit circle. So you would have to do x equals tan negative 1 of 3. If you were allowed to use a calculator, you would get that x equals 1.249. And what that's going to do is that's going to give you this reference angle in the first quadrant, which is where tangent's positive, so that would work for this one. You've also got to get the one that's in the third quadrant, but it's going to have that same reference angle. It's just going to be past pi. So to get the one in the third quadrant, I'll do pi plus 1.249. So when I add that, I get 4.390 if I truncate it. So those would be the two answers for when tangent of x equals 3. When tangent x equals negative 1 is in the second and the fourth quadrant, and that's at any pi over 4. So it's going to be at 3 pi over 4 and at, 7 pi over 4. Now, I paused, I'm sorry, because I'm just thinking about how we did not say from 0 to 2 pi. So in this case, it would be your 3 pi over 4 plus in pi, because that's our period for tangent. And that would take care of the other one as well, the 7 pi over 4. And then the other one, honestly, I would just say, because you won't be able to use a calculator in this next test, I would say tangent negative 1 of 3, and then you could say plus in pi if you wanted to. And that would take care of the general solution for you. All right, that's it for these notes, guys. I hope that makes sense. Talk to you later. Bye.